For as long as anyone can remember, people drilled holes by hand. The ancient Egyptians used bow drills in 3000 BC, spinning a pointed stick between their palms with a length of cord pulled taut across a curved bow. The Romans refined the mechanism. Medieval Europeans added metal bits. The tools evolved. The method did not. A man grabs a handle, he turns it. The bit bites into stone or wood or metal. One rotation at a time, his wrist aches, his shoulder burns. The hole deepens slowly. For centuries, that was the entire technology. Muscle, metal, repetition. In the workshops of late 19th century Germany, nothing had changed. A craftsman needing a hole in a steel plate reached for a hand drill, a device with a crank handle and a set of gears that multiplied his rotations. He leaned in. He turned. A single hole in thick metal could take 10 minutes of sustained effort. A dozen holes meant a morning's work. By afternoon, his hands were raw. The men who did this work were machinists, fitters, metalworkers. They built the machines that were building Germany's industrial revolution, and every hole they needed required their own bodies to make it. This was the world Wilhelm Emil Fein was born into on January 16, 1842, in Ludwigsburg in the Kingdom of Württemberg, in what would soon become the German Empire. His father was a craftsman. From childhood, Fein understood materials, mechanisms, and the distance between what tools could do and what workers needed them to do. He was not a theorist, he was a builder. By the 1860s, Germany was industrializing at a pace that had no precedent on the European continent. Factories were multiplying, railways were expanding into every province. Telegraph lines were connecting cities that had been isolated for centuries. The demand for precision, mechanical and electrical equipment was exploding, and the men who could build it were in demand. In 1867, at 25 years old, Wilhelm Emil Fein and his brother Karl opened a small workshop in Stuttgart for the manufacture of physical and electrical apparatus. The year mattered. It was the year the North German Confederation was formed, 2 years after the end of the American Civil War. The same year Alfred Nobel patented dynamite. The world was being rewired, and the Fein brothers intended to build the wiring. They had no investors, no corporate backing, no team of engineers. They had a workshop, a set of skills, and a conviction that electricity would change the way people worked. The company they founded was called C&E Fein. The C stood for Karl. The E stood for Emil. The name would outlive both of them. It was not a power tool company, not yet. The first products were galvanic batteries for generating direct current, induction coils for producing high-voltage electricity, and medical electrical devices. Hospitals needed instruments that could deliver controlled electrical stimulation for therapeutic applications. Laboratories needed reliable power sources for experiments. These customers paid well and demanded precision. Fein took that money and poured it into the thing he actually cared about: practical electrical machines that solved real problems in the physical world. In the 1870s, a new technology was spreading across Europe. Alexander Graham Bell had patented the telephone in 1876. The device worked, but barely. Transmission quality was poor, conversations degraded over distance. The hardware was fragile and expensive. Most people who had heard of the telephone had never used one. Wilhelm Emil Fein studied the problem. In 1877, he designed and built an improved telephone with a horseshoe magnet that delivered significantly better transmission quality than anything Bell or his licensees had produced. It was not a minor refinement. It was a functional leap. The voice came through clearer. The range extended further. The device itself was more robust. The telephone work led to something larger. Between 1882 and 1885, C&E Fein constructed the public telephone network for the entire city of Barcelona, a German workshop run by two brothers building the communications infrastructure of a Spanish metropolis. The scale of the project established Fein as a serious electrical engineering firm, not a local craftsman's operation. This sounds like a company that should be famous, a company that improved Bell's telephone, a company that wired Barcelona. a company operating at the frontier of electrical engineering, before most households in Europe had a single electric light. But telephones were not where Fein's legacy would be made. By the early 1890s, the Stuttgart workshop had grown into a proper manufacturing facility. Fein employed skilled electricians and mechanics who understood electric motors intimately. They understood power transmission. They understood miniaturization. They understood how to pack electrical energy into a housing small enough to be held in two hands. The combination was rare. Most electrical engineering firms of the era built large stationary equipment, generators, switchboards, industrial motors bolted to factory floors. The idea that an electric motor could be made small enough and light enough for a single person to carry and operate by hand was not obvious. It was radical. In 1895, employees at C&E Fein in Stuttgart did something no one in the world had done before. They combined a traditional hand drill with a compact electric motor. The result was a device that could drill a hole in metal without human rotation. The operator held the tool, pressed it against the workpiece, and the motor did the turning. It weighed 16.5 pounds. By any modern standard, it was enormous. It was heavy enough that extended use was still physically demanding. The motor housing protruded awkwardly. The cord tethered it to a power source. But it was the first electric hand drill ever built anywhere in the world. The original artifact still exists today. You can see it in the Deutsches Museum in Munich, Germany's National Museum of Science and Technology. It sits behind glass, a heavy iron-bodied machine with a cylindrical motor housing and a simple chuck. It looks crude. It was revolutionary. Every cordless drill in every garage in the world, every impact driver on every construction site, every surgical drill in every operating theatre, every industrial boring machine in every factory. All of them trace a direct line back to that workshop in Stuttgart in 1895. One company, one invention. The entire category of power tools began here. Fein saw the potential immediately. By 1908, the company had pivoted entirely to dedicated power tool manufacturing. Electrical apparatus and medical devices gave way to industrial tools. The workshop had found its purpose. Fein did not stop at the drill. The company had established something more valuable than a single product. It had established a method. Identify a task that destroys workers' bodies, then build an electrical machine that eliminates the physical cost. In 1906, Fein created the first portable electric grinder. Before this, grinding metal required either a stationary grinding wheel powered by a belt drive from an overhead shaft, or a hand-operated grindstone that the worker turned with a foot pedal or a crank. Both methods locked the worker to a fixed position. The metal had to come to the wheel. The portable grinder reversed the relationship. The worker carried the tool to the workpiece. The work stayed where it was. The tool travelled. The same principle Andreas Stihl would later apply to the chainsaw. Taking the saw to the tree, Fein had already applied to the grinder, the drill, the saw. The tool must go to the work, not the work to the tool. Fein arrived at that principle decades before anyone else in the power tool industry. In 1914, Fein introduced the first drill with an electro-pneumatic hammer mechanism. A standard electric drill could bore through wood and soft metal. But masonry, concrete, stone, these materials resisted rotation alone. You could spin a drill bit against a concrete wall for an hour and make almost no progress. The hammer drill added a percussive action, driving the bit forward with rapid impacts while it simultaneously rotated. The bit did not just turn. It punched. Walls that had required manual chiseling, hammer and cold chisel, blow after blow, could now be drilled in seconds. In 1927, Fein developed the first electric tin snips and the first jigsaw for sheet metal processing. Two more categories, two more tools that no one had imagined before Fein built them. In 1933, the company launched a dedicated jigsaw designed specifically for metal fabrication. By the 1950s, a compact drill called the Fein, the Fine Dwarf, became widely popular with tradespeople across Germany for its reduced size and exceptional reliability. Each of these was a first. Each created a product category that now generates billions of dollars annually across dozens of competing manufacturers. The electric drill alone represents roughly 30% of the entire global power tool market, a market worth over $40 billion today. And the company that invented it remained a name most consumers had never heard. The pattern was becoming visible. Fein invented, others scaled. In 1917, two Americans named S. Duncan Black and Alonzo Decker studied Fein's electric drill and introduced their own version with a critical design improvement, a pistol grip and a trigger switch. The improvement was real and important. The pistol grip made the drill easier to hold with one hand. The trigger gave the operator precise control over the motor speed. It was a better interface for the same fundamental machine, but the machine itself was Fein's. The electric motor driving a drill bit through a portable handheld housing. That was Stuttgart, 1895. Black and Decker took the invention, improved the ergonomics, and became the household name synonymous with power tools. Bosch entered the power tool market using the same foundational technology that Fein had pioneered. Metabo built its first electric drill in the 1930s. Makita, Milwaukee, DeWalt, every major power tool manufacturer in the world constructed their product lines on the category Fein created. None of them invented the electric drill. None of them invented the portable grinder. None of them invented the hammer drill. None of them invented the jigsaw. Fein did. All of them. The company never pursued mass market consumer sales. It never chased volume. It never positioned itself in hardware stores alongside cheap consumer-grade alternatives. Fein built tools for professionals who already knew what they needed, who could evaluate a tool by holding it, and who would pay for precision and durability over marketing and price. The strategy was deliberate. It was also invisible to the general public. The brands that copied Fein's inventions and sold them at scale became famous. The brand that invented the category stayed in the workshop, building tools for the professionals who already knew. Then in 1967, Fein did something that nobody in the tool industry or the medical industry had imagined. A hospital in Germany needed a better way to remove plaster casts from patients. The existing method was slow and dangerous. Doctors used manual saws or rotary cutting tools that risked slicing into the patient's skin beneath the hardened plaster. The plaster was rigid, the skin beneath it was soft, thin, and vulnerable. The margin for error was measured in millimeters. Injuries during cast removal were not uncommon. Fein's engineers studied the problem. They designed a tool that did not rotate. It did not reciprocate. It oscillated. The blade moved back and forth through a tiny arc, just 3.2 degrees, at speeds between 11,000 and 20,000 oscillations per minute. The movement was so small and so rapid that the blade required the physical resistance of a hard, rigid surface to cut effectively. Press it against plaster, it bit cleanly through the material. Press it against skin, it vibrated harmlessly across the surface without breaking it. The physics were elegant and specific. A blade oscillating through 3.2 degrees does not generate sufficient torque to sever soft tissue. It needs the rigidity of a hard material, plaster, wood, metal, fiberglass, to transfer enough energy for cutting. Soft tissue yields, hard material resists. The resistance is what makes the cut possible. This sounds like a minor technical detail. In a hospital, it was everything. Before the oscillating saw, cast removal meant a nervous patient watching a sharp blade approach their skin. Operated by a doctor who could not guarantee the blade would stop where the plaster ended. After the oscillating saw, the blade itself was incapable of cutting skin. The tool was intrinsically safe. The physics made the promise, not the operator's skill. Fein sold it to hospitals across Germany, then across Europe. The technology is still used in medicine today, in operating theatres around the world. Surgeons trust it with the same confidence they did in 1967. In 1985, Fein adapted the oscillating mechanism for a completely different industry. The automotive sector had a problem. Modern car windshields were bonded to the vehicle frame with silicone-based urethane adhesive. Removing a windshield without damaging the surrounding metal or its galvanized coating was a miserable two-person job. One person stood inside the car, the other stood outside. Together, they pulled an abrasive wire back and forth through the adhesive, sawing the glass 3 centimeter by centimeter. It took hours. It was imprecise. It damaged finishes. Fein's solution was to take the oscillating mechanism from the cast saw and fit it with contoured knife blades designed to slice through urethane adhesive. One person, one tool. The windshield separated from the frame in minutes. The metal stayed pristine. The galvanized coating remained intact. Within the automotive industry, it was revolutionary. In 1986, Fein brought the first triangular pad sander to market. They called it the Delta Sander. It used the same oscillating mechanism to sand into corners and confined spaces where no orbital sander, no belt sander, no disc sander could physically reach. It sold initially for $600 to $700. Window restorers saw its value immediately. Remodelers, fine woodworkers, cabinet makers, anyone whose work required precision in tight quarters. Then Fein's engineers realized the platform could accept far more than sanding pads. They developed cutting blades, scraping tools, grinding attachments, polishing accessories, one motor, one oscillation mechanism, dozens of applications. The operator switched tools in seconds. The result was the Fein MultiMaster, launched commercially in the mid-1990s. The world's first oscillating multi-tool. It could cut, sand, scrape, grind, and polish by changing a single attachment. In tight spaces on installed materials, in situations where no circular saw, no reciprocating saw, no jigsaw could physically operate, the MultiMaster worked. Fein held the patent. For over 20 years, Fein was the only company in the world that could legally manufacture an oscillating multi-tool. The MultiMaster was expensive. Professional-grade pricing, professional-grade performance. Blades cost $20 each and were frequently criticized as overpriced. But tradespeople who used the tool daily considered it indispensable. It did things no other tool could do, because no other tool was allowed to exist. The patent was a fortress. Fortresses expire. In October 2008, Fein's patent on the oscillating mechanism expired. The response from the industry was instant and overwhelming. Bosch released the Multi-X, Dremel released the Multi-Max, Rockwell released the Sonycrafter, Milwaukee launched its own version, then Porter Cable, then Craftsman, then Rigid, then Makita, then DeWalt, then a flood of budget brands from Amazon, Harbor Freight, and manufacturers no one had heard of. Within months, the oscillating multi-tool market that Fein had owned exclusively for 2 decades was fractured into dozens of competitors. The Rockwell Sonycrafter, priced at $180, hit number 1 on Amazon's Power Tool bestseller list. The Fein MultiMaster sat at $400. By 2010, the market was unrecognizable. By 2015, oscillating multi-tools were a commodity category available at every price point from $30 to $500. Hardware stores stocked entire walls of them, YouTube filled with comparison videos. The tool Fein had invented, developed, refined, and manufactured exclusively for a quarter century was now made by everyone. Fein had created the oscillating multi-tool market. And the moment the legal protection expired, the market that Fein created was handed to every company that had contributed nothing to its development. The same pattern that had played out with the electric drill in 1895 played out again with the oscillating tool in 2008. Fein invented. Others scaled, others profited, others became famous. Today, C&E Fein GmbH is headquartered in Schwäbisch Gmünd-Bargau in Baden-Württemberg, Germany. The company holds more than 700 active industrial property rights, including approximately 500 patents. It manufactures over 90% of its products in-house, made in Germany. Not assembled in Germany from Chinese components. Made in Germany, the MultiMaster is still manufactured. It is still considered the benchmark against which every competing oscillating tool is measured. Independent tests consistently rank it highest for vibration management, cut precision, blade life, and long-term durability. The tool and the blade were engineered as a single system. They were not assembled from the cheapest available components sourced from 3 different countries. In 2016, Fein partnered with Bosch to develop the Starlock mounting system, a new blade attachment standard designed for precision, security, and cross-brand compatibility. It was a pragmatic decision. If the market was going to be shared, Fein intended to define the standard by which sharing occurred. The company has 16 sales subsidiaries worldwide. It has never been acquired. It has never been absorbed into a conglomerate. It has never been gutted by a private equity firm extracting value from a legacy brand. In an industry where TTI owns Milwaukee, Ryobi, and Rigid, where Stanley Black and Decker owns DeWalt, Craftsman, Porter Cable, and Black, plus Decker, where KKR owns Metabo through Koki Holdings, Fein stands alone. Still German, still independent, still manufacturing in-house, still inventing. There are 3 types of motion a power tool can produce: rotary, reciprocating, oscillating. Fein invented the first tool to harness all 3, the first portable electric drill, the first portable electric grinder, the first hammer drill, the first jigsaw for metal, the first oscillating multi-tool. 5 category-defining inventions from a single company. No other power tool manufacturer in history has matched that record. Not Black & Decker, not Bosch, not Makita, not Milwaukee, not any of the brands whose names appear on the tools in your workshop. And yet most people who own a drill, a grinder, a hammer drill, a jigsaw, or an oscillating multi-tool have never heard the name Fein. They know Black & Decker, they know DeWalt, they know Milwaukee and Makita and Bosch. They know the brands that scaled the inventions. They do not know the company that made those inventions possible. Wilhelm Emil Fein died on October 6, 1898, in Stuttgart. He was 56 years old. He had founded his company 31 years earlier, at 25, in a workshop with his brother Carl. He had improved Bell's telephone. He had built Barcelona's phone network. His employees had created the world's first electric hand drill 3 years before his death. He did not live to see the tool change the world. He did not live to see other companies build empires on the foundation he poured. The drill must go to the work, not the work to the drill. That was the idea. It was not complicated. It did not require genius. It required someone willing to build the thing that did not yet exist, and a company willing to keep building for 158 years after he was gone. The original drill sits in the Deutsches Museum in Munich, 16.5 pounds of iron and copper and conviction. The oldest power tool on earth, built by the oldest power tool company still operating. Nobody put Fein's name on it.